Our next speaker is Wanheng Hu from Cornell University and Harvard, presenting his talk titled From Accuracy to Alignment, How Radiologists Work with and Build Trust in Machine Learning Algorithms. Thank you for joining us today.
Thank you so much, Liz, and thanks, Laura, for both of you for smoothing human-machine collaboration in the previous presentation. So my name is Wanheng, and I'm a PhD student in STS, Science Technology Studies at Cornell. I'm also a visiting research fellow at Harvard. So today I'm going to talk about the topic of trustworthy AI, and in the terms of human-machine alignment instead of collaboration, through the case of how radiologists work with and build trust in machine learning algorithms. So of course, trustworthy AI / machine learning is a very hot topic today, and especially in policy documents in different areas and around the globe. And of course, there's a huge amount of work dedicated to research about trustworthy AI. For example, these are 2 books on the topic. And in this research, as well as in these policy documents and the guidelines, there are 2 key elements. One is accuracy, the other explainability, which will be the focus of my talk today. So it's really important for algorithms to be accurate and explainable in order for us to trust them. So this is a web page of a research lab on trustworthy machine learning. It's a host of some major universities as well as laboratories in the industry. And again, you can see the importance of accuracy and explainability. So policymakers, researchers, as well as industry really pay a lot of attention to accuracy, especially in terms of explainability and trustworthiness. So there's a wide held assumption that if the output of AI is more accurate and more explainable, then these AI systems become more trustworthy and trusted. So this is an assumption that I hope to sort of challenge in this talk by asking, okay, trusted by whom and trustworthiness for whom? So that means I will switch to the perspective of users and talk about trustworthy AI on the ground. So I'll do this through the case study of machine learning products for rib fracture and pulmonary noodle detection on CT scans, which are the most popular software in the medical AI industry. I conducted a series of participant observations as well as interviews at different hospitals. So next, I'll just jump to a few observations that I made. Observation 1, it seems that in real clinical work, the statistical matrices for accuracy are not that relevant. First of all, many of the clinicians who use machine learning software actually don't know how accurate the models are. And in their real world clinical practice, you don't have the ground truth, which is very important to measure accuracy. So instead, they would always try to check the output of algorithms against their own judgment and always try to align them because this is partly because the limits of the probabilistic reasoning of algorithms. So even if the algorithm is very accurate in individual cases, you don't really know whether it works or not. And another important consideration is that of accountability. So because under current legal and regulatory regimes, like physicians would be the ones who are held accountable for the final diagnostic reports or whatever. So here's a quick quote from my interview on this issue. So my third observation is the irrelevance of a universal explainability. So when talked with these radiologists, what they really cared about is the outcome of these algorithms instead of the processes through which algorithms reason. And they're very often busy. They really want to keep their work efficient. So they're not that interested in probing into the reasoning procedures of algorithms. And they always say that, okay, we are clinicians. We care about how this tool works and if they can help us. So in terms of the explainability, that's the job of researchers. So they will always have their own ways of interpreting the outcome of the algorithms. So they will find patterns in the algorithmic output. And sometimes even if the algorithm makes a lot of mistakes, they still trust it because they know they can see the sort of pattern of those mistakes. And so they can make use of the useful part. So that's what I call, adjusted alignments. So these mistakes are explained away in this adjustment alignment. Okay, it's really relevant. It's coming again. So yes, here's another quote about this point of individualized interpretations and adjusted alignment. So the quick and preliminary conclusion is that notions of accuracy and explainability, which are rooted in algorithmic testing and designing, are sort of misplaced in conceptualizing users' trust in AI in real-world applications. So the trustworthiness of AI is a result of human-machine alignment and could not be reduced to some intrinsic features of the algorithms. So by saying this, of course, I'm not devaluing the work in current trustworthy AI machine learning. Those are still very important. So I think the implication is that even though on the one hand, when we strive to develop trustworthy AI in terms of all this, accuracy and stuff, they don't necessarily translate to trust and trustworthiness in real world applications. And on the other hand, well-accepted machine learning systems does not imply that, okay, they are truly trustworthy. So the competence and confidence and credentials and the work load on the human side are really important considerations in this process. I think I'll stop here in the interest of time. Thank you so much, and I look forward to your feedback and questions.
Thank you. That's one question,
Sure.
And then we will. Guy, you asked the last one. You can ask this one. Yeah.
I have a question about the ground truth. You said in clinical settings you don't have ground truth, but in the training you also don't have ground truth, right? Like, what is the ground truth? It's what the radiologist decided. Is that true, or is there like some deeper ground truth?
Yeah, that's a great question. So when I talk about ground truth, I was referring to the sort of consensus among a few radiologists when we do the training and when we do the testing. But in the real world clinical work, it is really the radiologist who is facing this output from machine learning systems. So it's just himself or herself. So they don't have the time or motivation to seek for a ground truth to judge output of the algorithm. So
Okay, we are going to have to move on, unfortunately. I'm really sorry. We're very behind time at this point. So let's thank the speaker one last time. And if you would like to share your slides afterwards, I'm happy to circulate them.
Sure.